Hi everyone, welcome everybody. I thank you everyone for being here to watch my video. Today we are going to learn about the lesson on class 9th, the chapter 1 set language. Please note the textbook page number 1 and textbook page number 2. In this video we are having the content of these two pages. We are going to learn about what is set language, real-time example, what is the language of sets, why we are using set language, and finite and infinite sets. We are going to learn these topics in this video. Okay, generally what we consider these kind of things in our real life, we say this as a collection of books, and this are the collections of stamps, and these are the collections of golden coins or coins, etc. So we are making a collection. If in your school you are asked to make a collection of stamps, and you are having a collection of books in your schools, your parents may give your penny savings as a group of coins or a collection of coins you will have. Likewise, we can see the collections in our real life. Now, what is the set language we apply here? We can see that the set language is there in this real life also, while making these as a set of books, and there are a collection of books inside this sets. The book is a set which has the collection of books, and stamp is a set and that has a collection of stamps, and coins is a set and that has a collection of coins. Now, set language is a mathematical way of representing a object. Fine. Okay. In the set language, we generally use a mathematical concepts like it is in the set or not. Is that the set contains an elements which is in the set or not? That is, A is belongs to A, or A does not belongs to A or not. We are going to learn these kind of statements in this set language. And also set language has a certain rules, and it has a usual figures to notify the sets, which is a Venn diagram. This is the language of set that uses a picture like this. This is called a common and usual diagram in a set language. Okay, why we are using this type of picture in our set language? Because this square represents the whole set and the circles represents the collections, and also this part area represents the both objects in a collections. If you are having two collections, then this area will represent you the objects that are present in both the collections. So this area is usually used for that, and this area is used for the used for denote the objects which are not in these collections. This area are used to note the objects which are not in these collections. And also this green side area, not this blue side, only this green side area are used to denote the only objects in that collections. Okay, this blue area denotes that the only objects in this specific collection. So okay, let's see an example for describing these Venn diagrams. These diagrams are generally called as a Venn diagram in a set language. Okay, for example, by considering a Venn diagram, we can have 16 students in a class who play cricket and 18 students in a class who play volleyball. And also we are having 3 students play both cricket and volleyball. Okay. And there are 2 students who never play cricket or volleyball. And in our class, there are 39 students. So, by the description of set language, how we can denote the 39 students and where we should denote the 39 students? Yeah, that is here. Here, we have a square that denotes the total number of objects in a set. And how to denote the students who never play any cricket or volleyball? Yeah, this is the area which is also to represent other than the objects which are not in these collections, which are not in our taken collections, or which are not in our determined collections. So we have to note this too as a students who never play cricket or volleyball. Now we have two collections here, that is cricket players and volleyball players. We have a collection of cricket players in a class and we have a collection of volleyball players in our class. So we have to note that who play only cricket in our class. There are 60 students who play only cricket in our class. So this is the area which is to represent the only objects which is present in a collection. So this is the area where the only object present in that collection. And volleyball players, we have to denote the volleyball players here. So we have to denote the number of students who play volleyballs here, because we have only 18 students who play only volleyball. Then we are having 3 students who play both cricket and volleyball. As I said, this is the area which is the combination of both collections, which has the objects which who are the combinations of the both collections. So here we are having uh, in our collections cricket and volleyball. There are 3 students who are the players of both cricket and volleyball. So we have to denote this 3 here. That is the concept of a set language. Okay. Now we have to know about why we are using the set language. Why it is most important in our mathematical concepts also. So we can make a view on that. So why we are using set language? One reason is that everyday language is imprecise, that is not clear, and can cause confusion. Okay, you are saying some collections and you cannot define how to explain that to your friend. So that needs some symbols or some colors. So in to specify a book, you can say it as a book. To specify students, you can say it as a students. But how to categorize those, how you can easily convey your ideas to them. For that only the set language is introduced. In our examples also, we can see that there is a collection of cricket students and the collection of volleyball students. But we have simply made the view like the circle, the whole circle represents a cricket collections and the whole circle represents a volleyball collection and their combinations. We didn't use any symbols or colors to denote it. Likewise, the set language is very helpful to define your data clearly to others. So, here we are going to learn about or see an example, which is we can consider numbers like 1, 2, 3, 4, 5, 6, etc. We can easily say these are the number series, or correctly for exact mathematical definition we can say they are the natural numbers. Okay, how we are specifying this as a natural numbers? Because we know the numbers which are comes under 1 to infinity are always called as natural numbers. So we can easily say this, and there is no difficulty in our argument, difficulty to agree on. Like in the previous lesson, we have learned. Here, when I asked you to, can you say a number which will be next to 4 in a multiples of 2? You can say the only answer, which is 6. So we have no other answers which is the multiples of 2 and next to 4. The only answer is 6. So likewise we can explain shortly as multiples of 2 or powers of 2 in a set. For example, if you are asked to make a collection of numbers which are multiple of 2, we can say like this: 2, 4, 6, 8, etc. are the collections of numbers which are multiples of 2. in case if we are asked for a question which is the power of 2. So we can obviously say that these are the powers of 2. 2 power 1 is equal to 2 and 2 power 2 is equal to 4 and 2 power 3 is equal to 8 and 2 power 4 equal to 16, etc. We can say like this, and these make a collection also, which is the collection of powers of 2. Okay. Likewise, we can making a collections in our mathematics, and this would be an infinite collections. That is the topic we are going to listen next. Okay, likewise, we are making the collections in our real lives also, and there is a finite and infinite sets also, and these collections are made as a set. That is why we are making a collection. Okay, now we are going to see about the collection which is infinite, and by the above example itself we can note that the collection of numbers which are the powers of 2 and which are the multiples of 2 are quite infinite set, because we can, by using the set language, we can shortly denote it as a power of 2 or a multiples of 2, but the set is still infinite, which is uncountable and undetermined. Okay. For example, to see that for a cup of sand, we cannot find the sand particles in this cup of sand. So this may be a infinite set. And also the prime numbers is also infinite, because for a 10 the prime numbers up to 10 we can say, and the prime numbers up to thousands also we can say, but the prime numbers to the crores we cannot determine. So such kind of prime numbers and such kind of sand particles are infinite sets. So not only these, but also we are having many infinite sets in our world and in our mathematics. Then for noting the finite set, we are considering a picture. Okay. In this picture, when I ask you which are the rose plants, we can easily note it as the rose plants has 1, 2, 3. We can easily count. We can easily say the rose plants present in this picture. So the finite set is that which is countable and can be determined. But the infinite set is completely uncountable and cannot be determined. Okay, these examples can make easy to understand the concept, and also we can say that the prime numbers of 1 to 50 is also a finite set, because we can say the numbers which is prime between 1 to 50. So that is a collection which also considered as a set. For considering a prime number between 1 to 50 as a set A, we can denote it as a set A contains the prime numbers which are between 1 to 50. We can explain and we can describe. So such kind of things are called finite sets, and you can clearly note that the infinite sets. Okay, next we are going to the concept. For example, when you are intersecting at 3 lines in a point, so that is a finite connection. When we are intersecting 4 lines, when we are intersecting 4 lines within a point is also a finite set. And describing a points in, that is describing each and every point in a line segments is quite uncountable and quite undetermined. So this is a infinity, and when we denote a points like P, Q, R, S, T, which are 5 points in a line segment, so this can be determined and countable. So this also a finite one. And also you can say that A is a line segment that has a 5 set of points, which is P, Q, R, S and T. So likewise we are representing a finite and infinite set. In our mathematics, we are having set language concepts and sets concepts in our algebra, graphs, geometry, etc. So we are learning set language. In algebra, we are asked for a question that you are having a three sketch packets. Take a green colored sketch packet and how many it is. This is an algebra, and when we are plotting points in a graph and finding the line segment which intersects those points is also an set language. And also we are here in this syllabus, 9th standard syllabus, we are just knowing the finite sets and its languages. Okay, it is quite easy only, so we can make a good grade in this chapter. So this is one of the easiest chapter. You can make it as very possible way for scoring marks. So in your book you are given these two pictures which is to represent that how to make a collection. The collection made as their characteristics. Like these are the collections which have the same characteristics, which is they are the fruits, and these are the collections which have the same categories, which is the electronic things or household things. When we are taking the fruit sets, we can note several collections and several sets because you may note it as the collection of apples in a fruit basket, the collection of grapes in a fruit basket we can make. But in general, we make a collection by their characteristics. This is the concept in these two figures. Okay, this is can also be made as a set. Okay, now we are in the final, and thank you everyone for watching my class. Up next, we are going to learn representation of sets and their examples. In the previous video itself, I have noted that we are going to learn next this, but for the kind knowledge on the set language, we are got a lesson on the set language. Okay, thank you for everyone.